Okay, this is question number 10 from the book Pathfinder, chapter Newton's Laws of Motion, subsection MCQ. In the setup shown, the string is inextensible and light. There is no friction at the axles of the pulley, but friction between the string and the pulley wheels is sufficient to prevent slipping. All the pulleys are light except the pulley P, which has whole of its mass M concentrated in its axle. Initially, the block B of mass M is on the ground and the block A is held at rest. How much minimum mass should the block A have so that after releasing it, the block B starts rising? Okay, so this is the question. First, consider a pulley and suppose friction acts on it like this. It can act either ways. I'm just assuming it to be acting in this direction. And this friction will produce a torque, that is friction into radius, and that torque will be equal to I alpha. This is a very famous formula. Torque is equal to I alpha, where I stands for moment of inertia. Moment of inertia in this question of every pulley is 0. See, some of the pulleys are massless, therefore their moment of inertia are 0. One of the pulleys has mass, but all its mass is concentrated at its center. So therefore its moment of inertia is 0. So using the formula torque is equal to I alpha, since I is 0 for every pulley in the question, torque must also be 0. And torque 0 means there should be no friction between the pulley and the rope. No friction will develop. As soon as friction tends to develop, the pulley will rotate due to that. So friction will not develop due to this. If there was a resistance, then friction would develop, and resistance means moment of inertia. Okay. So friction is 0. Now this is a rope going over the pulley and the tensions on either sides are T1 and T2. Consider the rope. Friction has action reaction, and since friction is 0, then we have this relations T1 will be equal to T2. If there was a friction, then these tensions would be different, and since friction is not present in this case, the tensions will be equal. Now consider this situation. Suppose the acceleration of block A is A, small a, that of block B is B, and that of pulley is C. Now since block B is directly connected to this pulley, so whatever acceleration the block B has, the same will be the acceleration of this pulley, so that is B. Find the constraint equation. Suppose this distance is x1 from ceiling to block A. This distance is x2, suppose. Similarly, this distance is x3 and this distance is x4. Y is the horizontal distance between these two pulleys is y, suppose. Now write the length of this string. See, the length of this string is a constant. So we can write this expression. x1 minus x2 is length PA. x4 minus x2, verify this. x4 minus x2 is the length of this string, the part of the string between these two pulleys. Similarly, the third term x4 minus x3, it is the length of this string, this part of the string, plus y, this is the length of this part, plus x2 minus x3, finally, this is the length of this part. So these lengths, summation of these lengths is a constant. Now since we have accelerations of block A as A, pulley P as C, and this pulley as B, now double differentiate this equation. So what is the double differentiation of x1? The double differentiation of x1 is plus A. Why plus? Because this direction of A will increase the distance x1. So the differentiation of x1 is plus A. The differentiation of x2 similarly is plus C, because the acceleration C is in such a direction which will increase this x2. So it is having a plus sign. So double derivative of x2 is C. Similarly, double derivative of x4 is minus B. See, x4 double derivative is minus B because B is upwards. So when the pulley moves upward, this x4 will decrease. So therefore, it's with a minus sign. Similarly, double derivative of x2 is c. Okay, we have seen earlier. Double derivative of x4 is minus b. Double derivative of x3 is not changing as these pulleys and blocks will move. X3 is not changing, so its double rate of change is 0. Y is similarly not changing. Y is the separation between these two pulleys, horizontal separation. It's not changing with time. And double derivative of x2 we have already seen c. X3 is not changing. So this is the expression we get when we double differentiate the expression we wrote using the length of string as constant. So from here we get b equal to a minus c by 2. Now consider the block A, and its acceleration we have assumed as a tension. This whole string will have same tension as we have discussed earlier. That tension remains same throughout because there is no friction. Friction is present, but it will not be developed because moment of inertia is 0. So the block A has these forces. Its weight, its mass we have assumed as m dash. So its weight, tension, and its acceleration is a. And so this is the acceleration of block A. And similarly, if you consider this part of and draw the forces and find its acceleration, that will come out g plus t by m. See from these two expressions, b is a minus c by 2, and what you're seeing that a is g minus something while c is g plus something. That is, c is more than a numerically. So a minus c is a negative quantity. So b will be negative. B being negative means b will be in opposite direction, in the direction opposite to what we have assumed. And since block B cannot go downwards, so this means that B can have only a value equal to 0. That is the only possible value because B means going downwards because it's coming out negative, and B cannot go downwards. So only possible value of small b is 0. And that implies A will be equal to C. So this block A and this pulley P, they will move as a whole with common acceleration. So this you can take as a single moving block. There is no relative motion in this block. They are moving together. Now when this block moves downwards with an acceleration a, so when this goes downward, the string connected from here to here, it will move like this along the arrows I have shown. So this pulley will rotate like this because the string is going in that direction and there is no slipping between string and pulley. So it will rotate the pulley. And similarly, this will rotate, while this pulley will not rotate. There is no movement of this string with respect to pulley. So this pulley will not rotate. This block is moving as a whole. So now we have our answers. So block B will not move or any value of mass of block A. This is one answer. And seeing the relative motions, all pulleys will rotate except the pulley P. Okay.